Welcome to our Pure Maths 1 Term 1 test series. This is question 2, so we're looking at our circle measure and our understanding of that. So we have this triangle here, and I'll read the instructions. The diagram shows triangle ABC, which is right angled at A. Angle ABC is 1/5 pi radians, and AC is 8, and the points D and E lie on BC and AB respectively. The sector ADE is part of a circle with a centre of A, so therefore AE and AD are obviously going to be equal, and this and is such that BDC is the tangent to arc DE at D. Okay, so BDC, this is going to be a tangent to the arc at this point here. Okay, it's a tangent. Alright, okay, so we've got this information. We have to first of all find length AD. Okay. Well, my first step would be to look at this triangle here. I know that this angle here is going to be pi over 2. And I know that this angle here is pi over 2. Since pi is 180, right? Okay, so 90 degrees is pi over 2. Therefore I can work out this one here, because this plus this has to add up to pi over 2. So I can calculate that pretty simply. And I also know that since these two triangles are triangle ABD and ADC, they are in fact similar. I know that this angle here is pi over 5, or 1/5 pi radians. And that leaves me to work out this one here. This is going to be 3 pi over 10. You can see this fairly easily. I hope if you think about 1/5 pi, that's the same as 2 tenths pi, and when you add 2 tenths and 3 tenths pi, that gives you 5 tenths pi, or pi over 2, which is the other 90 degrees of the triangle. So we've got 180 degrees here, and now we're in a position where we can work out this length of AD. So I'm going to work with triangle ADC. I'm just going to draw it here. I know this angle is pi over 5. And you can check that, of course, if you want to, because this and this must add up to 90 degrees, because it's a 90 degree here, or pi over 2, sorry, if we're working in radians, and it does, so we're good. We know that this is 8. We know that this is our right angle. So we want to find this one here. This is going to be our adjacent, and this is our hypotenuse. So we would go cosine pi over 5 is equal to the unknown, the adjacent, over 8. So 8 times cosine pi over 5 is equal to length AD. Therefore AD is equal to, at this point you can chuck that in your calculator. I'll just quickly do it on mine. Make sure, of course, you're set to radians. So it's going to be 8 cosine pi over 5. And I'm getting 6.47 as my answer to 3 significant figures. Okay, so that's part 1. And part 2 is the area of the shaded region. Okay, so the shaded region is this bit here and this bit here. So I hope you can see that we have, first of all, this here, pretty badly drawn, but you get the general idea. So this is the sector. So we're going to find area equals sector AED. And then, in addition to that, we are also going to need to add this bit here, which is plus triangle ADC. I hope that makes sense. If not, perhaps pause the video at this point, go back and have a think about it. At this point we need to consider, how do we do the area of a sector? Well, we have our formula half r squared theta when theta is in radians, and the area of a triangle is half AB sine C. So in this case, half this side here, which we worked out earlier, I would use my unrounded result, times 8 times sine pi over 5. It's a 5. Okay, well let's try this. 0.5 times radius, the radius in here is this, is actually half what we worked out here, 6.5, so 6.47 blah 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 squared times the radians of the sector, which is 3 pi over 10, and then we're going to add that to half times 6.47 times 8 times sine pi over 5. Now when we do this, and I will just quickly do this now to check that I have the right thing, equals 35.0 to 3 significant figures. So that's how you do the second question in the test.